Now we're going to start learning about series. And a series is when you're adding up all the terms or part of the terms of a sequence. So we have what's called summation notation. So the sum of the first n terms of a sequence is represented by some summation notation. So we use this big capital, this is a big capital Greek sigma. And it tells us we're going to add things up. So it tells you, this number tells you which term you're going to start with. This gives you the formula for the terms. And this tells you the term you'd end with. So I is the index, that just kind of tells you the variable that's in your formula. N is which value you're going to stop at. And I is, or the one down here, is the lower limit. So here, when we're saying you're going to add from 1 to 5, so you're going to add the first term up through the fifth term of plugging 1 in here, then 2 in here, then 3 in here, then 4 in here, then 5 in here. So first we plug in 1, so we'd have 12 over negative 5. Then we'd be plugging in 2, so 12 over negative 5 squared. Then 3, then 4, then 5. And we know to stop at 5 because this upper number is 5. So you can do that in your calculator. And if you do that in your calculator, you get negative 2.00064. So that's adding all of those values up. Okay, this next one says we're going to add starting with 1 and going up until we've plugged in 7. And we're going to add this formula. Now we're plugging the values in for I, not for x. So we'll have x's in our term here. So first if we plug in 1, we'd have 4 times 1 plus 2, which would be 6x to the first power. Plus, now if we plug in 2, we'll have 8 plus 2 is 10x squared. Then we'll plug in 3, which we get 14x cubed. Plus plugging in 4 would give us 18x to the fourth. Plus plugging in 5 would give us 22x to the fifth. Plugging in 6 would give us 26x to the sixth. And 7th is our last one since this is a 7. So plus 30x to the 7th. And that's our sum. Since, you know, here our sum happens to be a polynomial, we don't have anything that we're plugging in for x. Now we also want to be able to go the other way. So this says rewrite the sum using summation notation. So we're going to have our summation symbol, our sigma, okay, and we want to write this out a little formula. So notice we want powers of 2. This is 2, 2 squared, 2 cubed, 2 to the fourth. So we're going to go 2 to the I and say, okay, start with 2 to the first, and we have 4 terms running up 2 to the fourth. Okay, now here we're starting with 2, and notice what we're doing is we're adding 5 each time. And this is actually called an arithmetic series when you're adding the same value each time, and we'll learn about those. And we can actually write this out. It takes a little playing around, but as 2 plus, we're going to take 5, but we don't want to add 5 to the first one, so we're going to do I minus 1. So when you plug in 1 here, it'd be 5 times 0, which is 0. Then when you plug in 2, you'd be adding 5. When you plug in 3, you'd be adding 2 times 5, and so on. So now this is the first term, second term, third term, fourth term, fifth term, so we're going to stop at 5.